What if I told you that creativity, something we usually think of as wild, mysterious, and unexplainable, actually follows mathematical patterns? From the way artists generate ideas to how scientists make breakthroughs, hidden equations, and statistical rules shape our creative lives. Today, we're going to break down the mathematics of creativity, and by the end, you'll see imagination in a whole new way. Chapter 1. Creativity isn't random. We often imagine creativity as lightning sudden, chaotic, impossible to predict. But researchers like Dean Keith Simonton, a leading psychologist of creativity, argue otherwise. He studied thousands of works by composers, scientists, and inventors, and found something surprising. Creative success follows statistical probability. The more attempts someone makes, the more likely they are to produce a masterpiece. In other words, creativity has a law of large numbers. Think of Thomas Edison. He filed over 1,000 patents, most of them forgettable. But hidden in that pile were the light bulb and the phonograph. Same with Picasso. He created more than 20,000 works, but only a fraction define him today. Mathematically, it's simple. Quantity breeds quality. Every attempt increases the odds of a breakthrough. Chapter 2. Zipf's Law and Idea Distribution. But it's not just about trying more, there's also a distribution pattern in play. Enter Zipf's Law, a principle from linguistics and mathematics. It says that in any large set, the frequency of outcomes follows a predictable curve. A few things are extremely common, most are mediocre, and a tiny fraction are extraordinary. Apply this to creativity. Most of your ideas will be average, some will be pretty good, and a rare few will be brilliant. That curve shows up everywhere: hit songs, best-selling books, viral TikToks. Mathematically, most creativity is noise, but the signal is in the outliers. Chapter 3. Combinatorial creativity. Another formula for creativity comes from Margaret Boden, a pioneer in cognitive science. She argues that creativity is mostly combinatorial, taking existing elements and recombining them in novel ways. If you model this mathematically, it's like permutations and combinations. A limited number of building blocks can produce an astronomical number of new arrangements. That's why hip-hop sampling, meme culture, and scientific theories all feel new, but are built from recombining what's already there. Chapter 4. The 10,000-hour and exponential growth curve. Then there's the role of time and effort. You've probably heard of Malcolm Gladwell's 10,000-hour rule, though it's debated. It echoes a real mathematical truth. Skill follows an exponential curve. At first, progress is slow, but as hours accumulate, ability accelerates, and breakthroughs become more likely. Think of it like compound interest. The longer you invest in creative practice, the faster your growth rate. That's why mastery looks like magic from the outside, but underneath, it's math. Chapter 5. The chaos and order balance. Here's another fascinating angle: complexity theory. Creativity often emerges at what scientists call the edge of chaos, the delicate spot between total randomness and rigid order. Too much chaos? Nothing makes sense. Too much order? Nothing new happens. But in between lies the sweet spot, where unexpected but meaningful connections form. Mathematicians model this with systems like cellular automata, showing that the richest patterns appear not in pure noise, not in rigid repetition, but right in the balance. That's essentially where creativity lives. So what's the big takeaway? Creativity, it's probability plus combinations, plus time, plus balance. It's math hiding in plain sight. If you want to be more creative, the formula is simple. Produce more. Quantity matters. Recombine relentlessly. Mix old things into new forms. Stick with it. Time compounds your growth. Find the edge of chaos. Balance structure with freedom. The next time you think creativity is magic, remember it's mathematics at work. And maybe the real equation is this. Creativity equals attempts times combinations times time times chaos order. Thanks for watching. Don't forget to like, share, and subscribe if you want more deep dives like this.